Yep, so the recording has started. We are picking up where we left off, which is really doing the finishing touches of Python drawing for now. So over the past two classes, we learned how to draw things starting with lines and then rectangles, how colors work, how to fill areas in, and touched on some of the other capabilities that Pygame has that we didn't go a lot of depth into, such as drawing polygons or drawing multiple rectangles. There's a lot of draw functions that we didn't talk about in depth, but they all work very similar to the ones that we've talked about. And the documentation page is always a great resource for learning more about these kinds of things. Today's class, I will go over a little bit of review, a little bit of the homework, and then I also want to just take some time to demo and create a really basic program involving drawing in a way that we haven't seen before yet. And if we have time, I will pick up where we left off on talking about sound and music in Pygame. So that sounds good. Let me start my screen share. Oh, ignore that. So I'm gonna look at my code and I'm gonna start off by talking about a sample program I have on my screen. And this isn't exactly a homework solution because the homework solution was very open-ended, but it touches on a couple of things that you might have done or were the goals for this assignment. So we have a lot of the same code that's in every single program. So I'm gonna skim over that for now, but I'm gonna go back on that for the review. Specifically, the part for this homework was things like you might have created a color. You didn't have to do it this way. You can use some of the shortcuts that we've mentioned, but here's how you explicitly make a color in Pygame. Cyan equals pygame.color, and then you pass in 3 values. So here I'm passing 0, 255, 255. That means no red, a bunch of green, a bunch of blue. That turns into a cyan color, kind of a neon light blue. And here I do something similar, but instead of creating a color, I'm creating a rectangle object. And we talked a lot about coordinate systems and how rectangles work. For the rectangle, a rectangle is defined by 4 values. The top left corner, which is defined by an XY coordinate pair. So here, my rectangle starts in the top left, 0, 0. And then the next 2 values are not another point. It's the width and the height of the rectangle. So this rectangle has a width of 255, 255. Let me actually, maybe a typo, should be 250, 250. So this essentially is going to be a rectangle that covers the top left quadrant of our window. So if you take our window, divide it into 4 areas, it's the top left section. And that's just because our screen size is 500 by 500. So this rectangle covers up the top left 1/4 of the screen. Then here's one of the draw functions that we didn't talk a lot about in the previous classes, but this is how you draw a circle. And I did show an example of this, but it has a lot of similarities with all the other draw functions. You have to tell it what surface to draw on, what color to use, and then some information that's specific to the shape or the thing that you're drawing. So for a circle, what you need to tell it is where's the center of the circle and how big is the circle. So here, I'm also going to change this. I'm going to make the center of the circle 250, 250. So that means right in the middle of my screen. And this is the radius of the circle, 100. So that means it's a circle centered right in the middle, and it's 100 pixels everywhere from the center. Then here's where I use something kind of special. I don't do flip, which updates the whole screen. I only update an area of the screen. And here I use the rectangle that I created in line 8. So before I run this, does anyone want to guess what this should look like when I hit run and we see a window pop up? What are we going to see? A circle on a square. So Derek, are you saying we're going to see a full circle and then a full square somewhere on the screen?
No, a square and then a circle on top of it.
Okay. I think I see where you're going with that. Does anyone else want to make a guess or say what they think we're going to see? So I think the trick here is maybe if I do display.flip. So we've seen flip a lot. So flip will update the whole screen. And so this shouldn't be anything interesting. We're just going to see the circle that I draw, right? So here I have my window. The only thing I do is create this cyan circle right in the middle of the screen, right? And so now what I'm doing is I'm not flipping, which means updating the whole screen. I'm only updating a portion of the screen. And so if we run this, I'm going to rerun, you'll see what we get is this. So it's kind of like a circle on a square. The thing is the square isn't really drawn. It just looks like it because the rest of the circle is cut off. And the reason for this is because of how update works. And so what we're doing is we're still drawing the whole circle that's centered at the middle, that's 100 pixels from the center at all points. But now instead of updating the whole screen to show it to us, it's now only updating part of the screen. It's only updating the top left 1/4 of the screen. And because of this, we don't see the full circle. We only see part of it. And that's why I called this rectangle window. That's why I named it what it is, because you can think of this rectangle as kind of your window to the screen. If you're only updating this rectangle, you only get to see what happens in that area. Anything else that happens outside of this rectangle, you don't get to see. And so, for example, to show this off, if I move the rectangle around, so maybe I make it a little bit smaller. So I'm going to make it 200 by 200. You'll see now that we see a little bit less of the circle, right? So the circle is centered somewhere right here where my mouse is, and it's like this. But now instead of seeing a whole 1/4 of it, our rectangle got smaller. I changed the width and the height, I decreased it. And so now what we see is only a small portion of the circle. And if I go the other way, if I change the rectangle to basically the whole screen, then update is just gonna, it's basically just gonna update everything because my rectangle is so big that it just covers everything that would be shown anyways. So at this point, update and flip are essentially the same thing. An alternative is if I do something like the top left corner is 250, 250, and it's a very small rectangle, like only 10 width, 10 height, then it almost looks like I'm drawing, or maybe that's a little bit too small. Let's make it a little bit bigger. It almost looks like I'm drawing a square. And that's just because it's like a optical illusion almost. We're still drawing a circle, but again, we're only updating a certain area. And so we only see this showing up. In reality, we are still drawing the circle. I want to make that clear. If later on you update another area of the screen, then it's going to show up then. So just because it doesn't show up now doesn't mean it's actually being drawn. It just means that it hasn't been updated yet. And if at a later point you call display.flip, or if you update a larger area, it's going to show up all of a sudden. So you can use this for different effects, maybe. But yeah. At this point, I want to see if anyone has questions about the homework that they want to talk about now, or we can always talk another time as well. Anything that wasn't clear with this demonstration? I don't see anything in chat, and I don't see anyone trying to unmute. So I'm gonna leave this for now. This will get posted along with the rest of the code. I'm gonna switch it back to what it was at the very beginning because I think that looks the most interesting and we see the most of it. All right, so I do want to cover a little bit of review before getting onto the rest of the class today. And it's actually review of not really the last two classes, but just Pygame in general. And so I would want to make sure everyone feels comfortable with this code that I'm using every single time. So pretty much every single program that I've written in this class that I've shown you guys, that I've given you, has this rough template going on here. And so I want to take a moment. I'm going to ask you guys to try to explain to me what's going on here. I'll start it off. The first two lines kind of always go together. And the first line is importing the Pygame library. And this is important because this is how we get access to all the things that we've been talking about before. And the second line, pygame.init, kind of goes along with it. It just does some setup tasks before anything else goes. And it's just important. It just needs to be run. So these two lines, that's why they're there, to get access to the Pygame library and to set it up for us. So can anyone tell me what the next two lines of code do? They also kind of go together. Create the screen to drawn. Yes, so these two lines combined kind of just create the window that we see every single time. The window that pops up when we hit play. And this is pretty much the only way that we've seen to do it. Note that this could be combined into one line. So notice the first line is just creating a variable called size. And the second line uses it in this pygame.display.setMode function. So we could just combine this all into one line. So like we could just move this 500, 500 into here and it would work. But it's a split up for clarity to make it less complicated. And here is where we define the dimensions of our screen and actually creating it right here. And it's important to notice that this is how you get a surface object. So every time where I say we draw to a surface, this function takes in the surface. Here is our surface variable that we get. Pygame.display.setMode returns a surface to us. Then we have this while loop. And here, pretty much I've usually used while true. Here is some code. I've also skimmed over this. We probably will get to understanding what this is more in depth by the end of Python 3. But for now, what I can tell you guys is this is how we close the screen. So if we try to look at this, we're using some sort of for loop. We're looping through some sort of thing, this pygame.events.get, and we're checking if these events have a type of pygame.quit. And really briefly, this is the event that's triggered when you hit the X in the top right. So when I hit this X, it sends this event that's pygame.quit, and that's what stops our whole program. So if I actually, for example, if I say pass, that's not the right program to run. Let me run this one. Here, notice when I hit the X, I'm clicking right now. And you can maybe see the color change to show that I'm clicking, but the window is not closing. And that's just because we don't do anything when we get this event anymore. So if I get rid of what I had before, which is what closes the program, I can't really get rid of this window anymore. Don't worry, you're not stuck. You can always stop it by hitting this red stop button in PyCharm. So it is not something irreversible, but that's really what this code is doing, the for loop. And I think this is the most weird part of the code that I've given, but hopefully that makes a little bit more sense. So notice now when I've put it back, the X actually closes the window. All right, so here is the time thing that we covered in, I think, the second class. Does anyone different who hasn't said anything yet want to tell me what this line of code does? Pygame.time.clock.tick 20. Really, I want to know what does this 20 mean? Like, it's a number, but what does this number mean, represent in Pygame? I know you have your hand raised, Derek, but I'm going to see if other people are willing to answer. Maybe Evan, do you know what this line is doing? This line of code right here.
It's telling them how long to wait to update the screen.
Yeah, that's exactly right. So this controls how often really this loop runs. And so when we say 20 here, we're saying run this 20 times a second. Or more precisely, don't run this more often than 20 times a second. If you have something in this loop that takes a really long time to run, for example, if you have a command in here that just says, wait for 5 seconds, then it's gonna break. What this does is it prevents it from being less faster than you want it to. It can't prevent it from being too slow. That you just have to speed up your code. But this prevents the loop from running too fast. And we've seen this when we did like fill the screen with random colors. We didn't want to fill the screen really quickly or else it just looks really bad. You can't really see anything. And so we slowed down how fast it updates with this command right here. And so this 20 says 20 times a second. If I change it to 1, it means 1 time a second. If I do 100, it means 100 times a second. And so a smaller number means slower. And finally, we have this pygame.display.flip. We did just cover this, but maybe Alex, can you tell me what this line of code does?
I think for the like maybe I'm pretty sure it's the finishing code to like to actually make sure to I think update the whole screen.
Exactly right. Exactly right. So this is the code that updates our screen, specifically the screen that we created right here. And so again, in most of the code examples that I've provided, I did flip because I just wanted to update everything. We just did talk about an alternative update, which only updates a portion of the screen. But that's really the code provided here. This is what it does. So this is why it's our template. It's really basic. It just creates a screen and constantly updates it. And whatever we want to do, we just add it to this base code. And so now I want to kind of walk through a demo. I don't have a lot of slides for this, but I just want to walk through a demonstration of using the drawing tools that we've already seen in kind of a new way. And what that new way is essentially animation or just moving, changing images. So pretty much everything that we've drawn so far is just static. We draw it and it just sits there, which is pretty cool. But I think what's cooler is if we can draw something that moves around on the screen, right? And the reason why everything that we've drawn is static so far is there's two reasons. One, if you notice, in my solutions, I've been drawing everything outside of the loop. So it's only drawn once. It's drawn when we start everything up and it just stays there forever. However, even if we move this into the loop, we're not going to see any kind of movement. Does anyone want to tell me why that is? Like if I move this into the loop, I claim that the code is going to work exactly the same way, or at least it's going to look exactly the same way. Why is that? Maybe Esther, can you tell me why if I move this into a loop, and so that means I'm just doing this again and again and again, why don't we see anything like changing on the screen? No problem, Esther. Derek, do you want to say?
Because if you do the same thing a bunch of times, it will just be in the same place again and again, so nothing will change.
Exactly. So here, for example, the main thing I'm drawing here is the circle, right? And so if we look at this command, we're drawing it onto the screen, we're using the color cyan, and here is where we're drawing it, the center and the radius. And so if we do this 100 times, a million times, we're just drawing the same circle again and again and again. And so if you put it into the loop, yeah, it'll do this a bunch of times, but every single time it does it the exact same way. So essentially what's going on is it's just drawing the same thing on top of itself again and again and again. And so you're not going to see any kind of movement. You're not going to see any kind of change. And so that just brings me to the point of if you want something moving on the screen, there's two things that you need. One, you need to put it in a loop so it does it over and over, but you also need something to change as it's going in the loop. Because if it's inside the loop, but the values are fixed, then that's completely useless still, because it's just going to draw the same thing and you're not going to get the movement that you want. So the demo that I want to do is really to draw kind of a rectangle that's just bouncing back and forth on the screen. And if depending on the time, we'll see how much we can expand it. But this is going to be very similar to the bouncing beach ball example that we've seen before, kind of, I think, on the first or second day when I was just showing off what Pygame is. So the first thing I want to do maybe is just to draw a rectangle. I'm going to start with code that's not quite going to work, and we're going to modify it until it does exactly what we want. So I'm just going to write some helper code. First, I'm going to define a color. So I'm going to say red equals pygame.color, oops, capital C. And red is just 255, 0, 0. And so I'm just doing this so I don't have to type out 255, 0, 0 over and over again. I can just use the variable. And I'm just going to create a rectangle. I'm just going to draw a rectangle on my screen. So I'm going to say pygame.draw.rect, and every single draw command needs a surface, so screen. It needs a color, so I'm going to use the red. And then for the rectangle, I have to give it 4 points. I have to give it the starting top left, and I need a width and a height. So maybe my starting point can be, I don't know, 50 in the X, and I'm gonna make it towards the middle of the screen. So 250 for Y, and the width is gonna be 10, and the height is gonna be 10. Okay. And so if we take this and run it, we see a very small rectangle. Maybe I'm gonna make that a little bit bigger. So maybe something like 50, 50. Hopefully that's easier to see. So there we go. A pretty big square because the width and the height is the same. And it's just sitting there on the screen right now. And so this is what we've hopefully are familiar with at this point. And so here's where I want to start moving it. And so to start us off, I want to move this rectangle, have it slide across to the right. So I want the rectangle to start here and then just slowly move across the screen. And so to do this, I'm gonna first do one thing to help us. I'm gonna say the rectangle X coordinate, I'm gonna make that a variable. And so initially it's 50, right? So initially it's 50, and I'm just gonna put that here. So notice, or rect X. So notice I've changed my number to a variable. And you might guess that I'm gonna want to update this variable later on. But here, I'm drawing the rectangle, and instead of using a fixed value, I'm using a variable. And the second thing is I'm gonna take this and I'm gonna move it into the loop. So maybe right here. So it's all this code is what we've seen before. I'm making sure it only updates 20 times a second. I'm drawing the rectangle and I'm flipping the screen. So at this point, I'm gonna run it and you're gonna be disappointed to see that it looks exactly the same as before. So that's just because we're missing one step still. And so can anyone help me with the step that I'm missing? Why is this not moving right now? Why is the square just sitting where it is at the start? So maybe David, do you have an idea of why the square is just in the same place all the time?
Are you changing anything?
You're exactly right. We're not changing anything right now. And so that's why it's staying still. And maybe David, then what do we want to change if we want it to move across to the right?
Could you do like rect X plus 1? Or what?
Great.
Yeah.
Yeah. It's exactly that pretty much. So we want to update this rect X variable. And so we want to do it inside the loop because we want to update it again and again and again and again. Right? And so the only thing that's slightly different is that we don't want to do rect X plus 1. We need to store this back into our same variable. We need to update it. So we need a little bit extra. Rect X equals rect X plus 1. Alternatively, another way, a shortcut, I'm going to put it in the comments, rect X plus equals 1. And so again, this plus equals operator, this is back in Python 1. This is our increment operator, essentially. It adds and then stores. So these two lines do exactly the same code. And for example, something like this, these two are the exact same as well. So this line of code is basically saying, take this variable, add 5 to it, and then put it back into the same variable. So it increments it by 5. And so if we run this, we're going to start to see something new. But I think I'm just going to make it 1 for now. We're going to very clearly start to see something that we don't want. And so if we just look at it for a second, we see movement, which is exciting, but something is wrong here. Maybe Wenqian, can you tell me what's wrong right now? We want the square to be moving to the right, but it's not quite what we want right now. It's a little bit off. What's wrong?
I kind of don't know.
All right, so I guess I'll tell you what's going on, and maybe you can help me think about how to fix it. So we want the square to be moving across to the right of the screen, and it's kind of doing that, but it's leaving behind kind of a trail, right? So we can see all the previous squares still. And so can you think of a way of maybe how to fix that? We only want to see the most up-to-date square.
Maybe make like the Pygame thing, like delete all of the previous squares.
Yeah, so that's exactly the right idea. Maybe Derek, do you want to tell me like concretely how we want to do that?
Like move the other part of the square.
Oh, okay. So I hear what you're saying. So that's not quite right. And the reason for this is because let me actually do something that maybe will show something interesting. So if I'm not going to use red all the time, I'm going to use a random color. So to do that, let me just define it here. I need to import random. Random.rand int from 0 to 255. And I want 3 of these. So this is my random color. And instead of using red here, I'm going to use a random color. And for demonstration purposes, I'm going to move it a little bit faster. You can see this. Right, so this maybe is a little bit more clear of what's going on. And I know, David, you had your hand raised earlier. Do you want to maybe provide a solution of what we can do to fix this problem?
I'm actually not sure now.
No problem.
Go back to the code.
Yeah. And it's a little bit longer now because I have this random color here. But that's just to show that if we look at the screen, it's not that our rectangle is getting stretched in any way. The rectangle is still a square. It's always a square. The problem is the previous rectangles or squares or whatever you want to call them are being left behind. And Wenqian did tell us we want to get rid of these old rectangles somehow. We want to delete them. The thing is, we're not actually gonna like delete them. It's not like we have an object that we're gonna delete, but there's another way of doing it. And so I think I'm just gonna reveal how to do it because it's, once you see it, it's gonna make a lot of sense, hopefully, but it is kind of a new way of thinking at first. And so the way we delete these squares, so to say, is to just draw a new background on top of them. And so what we're gonna do is we're just gonna refill the screen with black before we draw the square again. And so that way, what's gonna happen is we draw the square, and then the next time the loop runs, we fill the whole screen with black. That means we get rid of everything. And then we move the square and redraw it. And so it looks like it kind of moved over. And that way, since we filled the screen in with black in the middle, we don't see the previous square, because when we fill, we draw on top of all the old stuff. We kind of just cover it up. And so really the idea here is that we're not like deleting things, we're just covering them up. We're gonna hide them underneath something else. And so what we're gonna do is, first I'm gonna move this back to just being red, so I don't have this really long piece of code. But I will keep it around if I need it later. But what we're gonna do right before drawing the rectangle is just the screen dot fill, and here I'm gonna define another color. So I'm not gonna define red, I'm gonna define black. And that's gonna be 0, 0, 0. So black is nothing, essentially. No red, no blue, no green. That's just the color black. And so I'm gonna fill the screen in with black. And so if we run this again now, hopefully we'll see. Now is kind of what we wanted, right? So now it actually looks like the square is moving across the screen. And the reason why we don't see the old rectangles anymore is just because we're filling in the whole screen with black every single time. And so that means everything that we've drawn beforehand gets kind of deleted. And so, for example, I'm gonna make this really slow. or actually that's not that slow. I'm gonna make it like 5. So maybe we can see it. And so you still can't see the screen being drawn black, but this hopefully gets you an idea of what we're doing here. We have a square and it's just like moving across the screen. We're increasing the X value little by little, right? And that's this +5 right here. So again, a lot of things that we did. We drew our rectangle, and that's the old stuff. We know how to draw rectangles. The new stuff is that now the rectangle that we're drawing is not fixed. It's changing because we changed this variable. Instead of using a number here, we're using a variable. So that allows us to change it. We want to increase the variable every time the loop, so it's different. And to get rid of all the old stuff, we fill in the screen. So we get what looks like movement. So again, all of this is kind of illusion, right? It's not actually smoothly moving across the screen. It's kind of being choppy, but it looks smooth because we're updating it really fast. So for example, if I update it at 60, then this looks a lot smoother. Like you can't see the jumping anymore. And that's just because it's updating really, really fast. There is one last problem that I maybe want to fix though, and that's moving across the screen or losing our rectangle, right? It's moving, but it just slides across the end of the screen. It just goes off forever. But what I want is maybe my square to bounce back and forth. So once it hits the edge, it will move backwards again. And so I'll provide some hints for this, but I also do want some help from you guys. So the first thing is, how do we move backwards? I think that's the easier question. Maybe does anyone want to, okay, Derek, I see you have your hand raised. How do we move our square backwards?
Decrease it by 1.
Exactly.
Decrease the
So
X.
yeah. So if I change this +1 to -1, we're not going to see much right now, but you'll see our square is now moving to the left. And that's just because we're changing the X value less and less and less, which means we're moving to the left. And so that's how we move to the left. Very similar to moving to the right, which is plus versus minus. The little bit harder question is, well, there's 2 questions that we have to still solve. How do we know when to change direction? And how do we actually change direction? In the sense that we know that we want to change the plus to a minus, but we can't just manually do +1 or -1 right here. We need some other way of controlling that. So we need a way of controlling it, and one way of knowing when to switch. David, I see your hand raised. Do you want to provide an answer to one of those, or do you have a question?
We do like a true or false and an if statement.
Sure. So that's a great suggestion. That's one way we can do it. So up at the top, at the very beginning, I'm going to create a Boolean variable. And so I think this is what you're going for. I'm actually going to make a Boolean variable like go left or go right, since initially we're going right. So go right is going to be set to true. And so if this is true, we're moving our square to the right. If it's false, we're going to move it to the left. And so in here, we say, if this variable, go right, we want to say the X +1. Else, if this variable is false, then we want to go to the left, right? So we do almost the exact same thing, except instead of +1, we're doing -1. And so if we run this now, first of all, I'm going to change the starting position to be closer to the middle, so we get to see it better, left and right. So right now it's going to the right. And for now, I'm still going to do this manually. If I change this true to a false and save and run, we're going to see now it moves to the left. So we have some way of controlling the direction now. We have this variable, this true or false. If it's true, we go to the right. If it's false, we go to the left. And so now the last question is, and I think the trickiest question is, how do we decide when to change this variable? How do we know when to decide if we are true or if we're false? Dirk, you have your hand raised.
When X value is 500, change it to true, and then wait, no, false. And then when when the X value is 0, change it to true.
All right, so you're hitting it on the spot. We might have to modify it a little bit, but I'm gonna do exactly what you said. So if the rectangle, if the X coordinate is, did you say is 500 or what do you want here? Equals, greater than, less than, what do you want?
Equals 500.
So if the X value is equal to 500,
That
then what do we want to do?
set the go right to false.
Exactly, because if the X value is 500, that's essentially the edge of the screen. And so if it's at the right edge, we want to start going left now. So we want to set this variable to false. And then we want to do something exactly the same for the left edge of the screen. So if rect x is equal to 0, I'm going to just do this for you, go right equals true. Right. So if the X value is at the left, we're going to start going to the right now because we've hit the edge and we want to go the other way. And so I'm going to make this run a little bit faster. And I'm going to run it, and there's kind of two very unclear, two very subtle problems right here. So I think we see one already, but the left edge is perfectly great. It looks amazing, right? The right edge, though, there's something a little bit off, right? It's still going off the edge of the screen. Sure, Alex. So rect x is just a variable, and it's just essentially the starting position of our rectangle. So here I just say it's 250, which means that it's kind of in the middle. And we're using it in our draw command. We're using it as our x coordinate of our rectangle. And I think this goes into kind of the problem that we're having right here. So again, the left edge is fine, the right edge, not so much. And so a hint of why this might be is because of how this rectangle is being drawn. You have to remember what this rect x value is. This is the x coordinate of the top left corner of this rectangle. So if it's like the x coordinate of this corner right here, the top left corner. And so maybe that helps us to realize why the left edge is fine, but the right edge is not. And so the left edge is fine because when the x coordinate, the top left corner, is 0, that means the left edge of the square is touching the left edge of the screen, because the rect x is exactly the coordinate of the left edge. However, we're only bouncing when this top left corner reaches the right edge of the screen as well. But that's not exactly what we want. We want it to bounce when the right corner is touching the right edge. That way it doesn't go off the screen. And so Dirk provided one solution that we can do, and I like that for now. So we're just going to change this value. And so Dirk said 450. Really quickly, Dirk, can you explain why 450? Why did you choose 450?
Because the width is 50, so you have to do it 50 like things less. So it's 500 minus 450, which I mean 50, which is 450.
Exactly. So it's depending on the width of our rectangle. Maybe I'm gonna try to draw this out on Paint. I don't have my tablet with me, so you're gonna have to bear with me. But if we just draw our screen really quick, our screen is just some sort of rectangle. It's a square, but it doesn't have to be. And then we draw the square that we're moving around, right? And let me just fill this in with some red color. And what we're doing here is we're taking this square and we're moving it to the left. And then we bounce and we want it to move to the right until it hits the right edge of the screen, and then it bounces again and then goes like that forever. And so the thing I wanted you guys to remember and what we've recall is that when we have this variable, this rectx variable, it's really this corner, or it's the x value of this corner that we're storing. That's what this variable tells us. And so if we do this kind of fake animation again, we want it to bounce the left edge when this x value is 0, because that's when the left corner hits the left edge. However, we don't want to bounce when the left corner is at 500, because that looks something like this, right? This is when rectx equals 500, and we're already off the edge of the screen. We want to do it earlier. We want to do it when the right corner is touching the edge of the screen, right? And so what is this value? Well, it's 500, this edge, minus however wide this square is, right? And so that's why we have 450 here, 500 minus 50. Notice when I'm drawing this square, it's a 50 by 50. If I purposely mess this up, for example, I want to make my rectangle a little bit wider. I want to make my rectangle actually a rectangle and not a square. And I make it twice as wide. You're going to see it kind of breaks again. So you're going to go off the edge a little bit and then bounce back. And that's just because the value that we wanted, the 450 or whatever, is supposed to be the size of the screen minus the width. And so if I change the width, I have to change that number as well. And this is just a side note I want to make kind of important. It's good to have variables instead of hard-coded values. And the reason for this is, well, this is important when values are dependent on other values. And that's because if you update one and you're using hard-coded values like we are right now, you're going to have to update the other value as well. But if you're using variables, like I'm going to show now, you don't have that same problem. So if at the top I define a variable called like width, and I set that to 50, I'm saying my rectangle has width. And here instead of 450, I'm going to do 500 minus width. And this way, if we have it as it was before, it works normally with this square. I'm just going to wait till it bounces. You can see it works normally. But even if I have it like a really weird looking rectangle, a really wide one, it's still going to work. And that's because now I have it as a variable. If I update this one variable, it updates in a bunch of different places. So now you can see, even if I make my rectangle really wide, it's still bouncing correctly. There's one last thing, one last problem. It's very, very hard to see. So I don't blame anyone for not seeing it. But to make it happen, I'm going to do something like this. Instead of +1, I'm going to do something like plus 1.3 or something, minus 1.3. I think this is a show. Yep. So do you see our code broke? Our rectangle just slides off the edge of the screen. Right. And yeah, so I see question marks in chat. Does anyone want to maybe guess why this is happening? What it was working perfectly fine before. It was bouncing off the left edge and then bouncing off the right edge, but now it just slides off. Derek, you have your hand raised?
Is it that like 1.3 isn't like go into 500?
Yeah, it's related to like divisibility and stuff, but yeah, exactly. So I think with 1.3 it's a little bit hard to see, but I'm gonna go back to this drawing right here. So imagine that our square is bouncing around And at some point it reaches like really close to the edge, but not quite at the edge. And so maybe the x coordinate here is something really small. It's like maybe we'll say it's 2 for now, right? It's 2. And so the next step, we're going to the left. So we subtract by 1.3. 2 minus 1.3 is 0.7. So it's a little bit closer to the edge, still not touching it yet. And then what happens with the next step? The next step, it's currently at the x value is currently at 0.7. We do minus 1.3. That gives us a negative value, right? It skipped past 0 completely, right? It went from 0.7 to minus 0.6. And so if we look at the code that controls our bouncing right here, we can see a problem here. It only checks if the x coordinate is exactly some number, but we don't want exactly some number. We want some sort of like cushion for us. It's not just if the rectangle x coordinate is 0, it's also if it's anything negative, right? If it somehow went past the edge and went into the negatives, we still want it to bounce, right? We still want it to bounce even if it's negative. And same thing for here. We don't want it to bounce right when it's 500 minus the width. We want it to bounce if it somehow, some way gets a little bit past it, we still want it to bounce to the left, right? So instead of equalities, we're gonna do inequalities. So I'm gonna do something like this. If the rectangle x is greater than or equal to this value, this special value, then I'm gonna bounce. If it's less than or equal to 0, I'm gonna bounce. And so this will fix the problem that we have, because we have some sort of like cushion built in. If it somehow skips past exactly 0, it will still bounce the next time, because it will, if it skips past 0, it'll go into the negatives, and then it says, oh, you're negative, I'm gonna change that variable to true. And the same thing with the other end. I'll notice that if I kept one of them as concrete, yeah, if I kept this as 500, the left edge works because we have the inequality now, but the right edge still won't work. It'll still just fly off the edge of the screen. So we really need these inequalities, even if we're in a case where it doesn't matter. So before, when this was just 1, it didn't really matter if we had exactly or these inequalities. But you never know when someone is going to change your code, change anything values. You don't want it just breaking randomly. So it's better always to be safe and use greater than and less than, even when you know it shouldn't skip past these values. You never know what will change in the future. So always be safe. Better safe than sorry. So this is pretty much everything I wanted to cover about like movement / animations. I showed this example with just a square, with just a rectangle, but you can imagine going on to do similar types of ideas for maybe different shapes or even lines, right? If you change the endpoints for your line segment, it will change how it's drawn as well. So you can animate a line as well. Really, the principles I want to focus here are that if you want some sort of animation, you need to put it in the loop, so it goes again and again and again. And you need some sort of value that's changing. Here, it's the x coordinate that I'm changing. You can also imagine, maybe I'll actually do this as the homework. So I will post this code up on Classroom, up on the GitHub. I'll give you this. And I want you to expand it, essentially do the exact same thing I did for the x value, but I also want you to do it for the y value. So I don't want it just bouncing back and forth. I want it to be bouncing left and right, but also up and down. So essentially what you're gonna do is copy the same code, or yeah, you're just gonna copy the same code that we did to modify rect x. And you're gonna do something like, you're gonna make a rect y value, and then you're gonna change this fixed value to a variable. You're gonna have to figure out how to modify it, how to handle the flipping. You're gonna have to do something very similar to here. 500 minus the width, it's going to be something related to the height this time because we're dealing with y values. And yeah, also remember that down means positive, right? So if you want to move down, y is going to get larger and larger and larger. And so that's another trick. But otherwise, it's pretty much going to be follow along what we did right here. And so that will hopefully make you a little bit more comfortable with drawing and with the loop and Pygame in general. So, and that's going to be the homework. Just expanding this so it bounces up and down as well. Does anyone have any questions about this demo right here? Anything that wasn't clear? I'm happy that pretty much everyone was able to answer something, and I feel good about that. Yeah, so just a couple of notes that I want to make about this program before I give to you. Remember, I made a point of like doing this using a variable here instead of just like 50. It wasn't something necessary, but it's something that makes your life a little bit easier. But notice I'm still hard coding a lot of values. Like maybe 0 is fine because 0, it's always the left edge is always going to be 0. But here I have a hard coded value 500. This value should be the same as this value right here. And so maybe it would be a good idea to make a variable like screen width equals 500, and then change this to screen width, change this 500 to screen width. And so the idea here is that instead of putting 500 in 2 different places, I replace them with a variable and just define the variable in one line right here. And so this way, if I wanted to make my screen maybe smaller, or can't make it that small, but then change it like this. If I make my screen a little bit narrower, it still works. Things like that. So you can always go more and more with defining variables instead of hard coding values. You do have to draw the line at some point. Maybe you want to change all the values into variables, or maybe there's just some of them that are important and others that are, yeah, they're hard coded, but they're probably not going to change. So it doesn't really matter. It's really up to you to decide. But that's just a general programming tip that I wanted to make sure is said for this thing. But otherwise, if I don't have any other questions, that's pretty much all I think I'm going to cover today. Didn't have time to get more into sound, which is fine. We're going to cover that next week. And yeah, so homework is just going to expand this, and we'll meet again next week in class. If you don't have any questions for me, you're free to go. Otherwise, I'll be sticking around to answer any questions that you may have.